Okay, good.
All right. So with Newtonian mechanics, as I described, specifies that if you have an object that has mass evenly distributed, then your rotation curve is going to be flat. If you have mass that is centrally concentrated, like the solar system, then the disk is going to fall off in a Keplerian way, p squared over a cubed kind of way. So Newton predicts both of those. So it's not a problem with Newtonian gravity. Um, and, again, so Vera Rubin's observations, the problem was um, that there was dark matter there, or there was matter there that couldn't be accounted for. Your observations that you quote in the 30s, I believe those are from Fritz Zwicky, who was a very interesting individual. I think one of the reasons why he was disregarded is because, well, he was kind of an asshole. He threatened to shoot one of his co-authors. So there might have been some kind of personal grudge there. In terms of dark matter, there are two, and I hate these acronyms, but there are two competing camps. There are those that are machos, massive compact halo objects, and then there are WIMPs, weakly interacting massive particles. One of my colleagues at Georgia State, he is firmly in the macho camp. He believes machos are normal baryonic matter that is simply low luminosity, meaning that it's just not bright. And as is often been touted, you have the inverse square law of light. So if you have a very dim object that's very, very far away, you need exceedingly sensitive equipment in order to actually see it at all. But from a gravitational standpoint, you can notice its effects. So machos, their explanation is that what we're seeing are just really low mass stars, or dark matter is really low mass stars, exoplanets, white dwarf remnants, neutron stars, black holes, that sort of thing. So there is a camp, although the evidence is moving against them, but there is a sizable camp in astronomy that believes that dark matter is in fact normal baryonic matter. It's just really dim. WIMPs are weakly interacting massive particles, and so there you have essentially kind of two camps-ish. You have the camps that believe that the best explanation for dark matter is neutrinos, which are massless particles that have been detected. The only problem is that they are very, very high energy, and what the models are telling us is that dark matter needs to be cold in order for things to work well. And then you have in the other camp in the WIMPs, which I have not studied very well because so far they haven't detected any of their exotic particles like axioms or what have you. Until they actually find something, I'm really not going to invest myself into looking into it. So that's basically the current state of dark matter in astronomy.
Yeah, so I just made up. I mean, yeah, no disrespect, but it's just made up stories. That's what that is. Like, oh, well, maybe it's just there's matter there. It's just invisible, or that's a cool story. There's no evidence for that, and there, I guess you would automatically have to disavow any type of claim that says that they're able to find some of it on the Earth or anything like that, right? Like a CERN, all these stories. Obviously, any belief that it's baryonic matter you would have to disavow all claims at CERN, claiming that they are able to like briefly concentrate dark matter, which is pseudoscience. So I would of course agree with anyone disavowing it, but so 84% of the matter in the universe is really dim matter that you just can't see. Another major problem, there's so many problems with heliocentrism as a bias. So like the whole universe has to accelerate. And for the audience that doesn't know, right, that wasn't the initial prediction. We were supposed to see chaotic stuff happening all over the place. We're just a tiny speck of dust out here observing everything around us. But everything's moving like we're in the center. Then they came up with the balloon analogy that he said. Basically, like there is no center. Everyone's going to look like it's the center, which is convenient. And so now everything must be accelerating away from us, expanding in all directions. And so we fast forward to now. And so you have the cosmological constant, and then you have the Hubble constant. and we have these don't work at all. So we have what's it called, the Hubble tension, right? Though the Hubble tension is this huge discrepancy between like the predicted value based, or the, I guess what they call it, the measured value on like the closer galaxy scale, right? And then like these observations of supernovas, and the rest of, and the cosmic microwave background and stuff like that. When they combine these two, the discrepancy is huge. What is it, like 60? It's almost like 10 kilometers per second per megaparsec off. It's like 60, yeah, it's like 67 to 78 or something like that. So that's a lot.
Closer, but yeah.
Well, yeah, so it's wrong. It's drastically wrong. And so none of it works. I don't understand. Okay, maybe you can help us understand the Hubble tension. Explain to us what that is. And I'm going to be dissatisfied with, it must just be that our measurement devices aren't good enough. But if you can kind of explain maybe what you think about that, because, yeah, or, you know, the audience may not really even know what the entire, basically you have the idea that the universe is expanding in all directions, and you have the idea that a certain amount of energy has to exist to make this happen, simply put. And then when they look out into the sky, there are huge discrepancies based on how much this is supposedly happening in different locations, when it should just be happening the same everywhere. So what is maybe your take on that, the Hubble tension?
Okay. Well, before I get into the Hubble tension, you say cool story, bro. And really what I'm saying is these are hypotheses. So in a sense, yes, they are stories, but from a scientific point of view, these are hypotheses that need to be tested. And ironically enough, for your audience, one of the places that they're testing it is in Antarctica. The ice cube is I can't remember how big it is. It's a huge neutron detector or neutrino detector in Antarctica, and it's attempting to resolve the cold or the hot, cold, dark matter thing. As for what CERN's doing, again, I'm not certain what CERN is doing, so I can't really say anything about that. But these are not. We do not. Well, if anyone tells you that this is settled science, they're lying to you. We just know that there has to be matter there for galaxy rotation to work, for galactic clusters to work, for a couple of other different reasons. So, but we don't really know what it is. We have hypotheses, but we are in the process of testing them. It's one of the reasons why JWST was commissioned. Now, Hubble tension. No, you're right. You are absolutely right. There is, in fact, a tension. One of my other colleagues at LSU, he was really troubled by it. Johann Frank. So you have two different ways of determining the age of the universe. You can do it by looking at basically Hubble law. You can look at distances of galaxies with respect to their velocities. And essentially that's a linear function. You take, in a simplistic way of looking at it, is you take the reciprocal of the slope, and or the slope is your Hubble constant, and then you take the reciprocal of that, bing, bang, boom, you have a time. You have an age of the universe. Then you actually can look at the cosmic microwave background, and this is the age that often gets quoted, the 13.7 billion years old, and you find that there is, by looking at essentially the sizes of the quantum fluctuations within that field, you can also derive an age. I'm not entirely certain how they do it, but that's how it was explained to me. And I've seen the data, I've seen the various experiments that have been done. And you're right, you are very valid in that the two are not statistically consistent with one another. Hubble law Hubble, through the Hubble law, it's more like 72, 73. For CMB, it's more like 68, but the error bars on both experiments are small enough that they don't statistically overlap. They do not agree with each other to definitely 1 sigma, possibly even 2. I'd have to go back and look on that. But that's that is openly being questioned, that is openly being studied. It's not something that we just throw under the rug and we're not looking at it. So
but wait, isn't that be isn't that a huge deal though? Like, isn't that like incredibly pivotal to everything? Like the cosmological constant and the Hubble constant. I don't see how that's not a big deal. I guess is what I don't understand.
It is a very big deal. And so, but it is a very big deal in our understanding of the cosmology as a whole. But on a smaller scale, it says nothing about the Earth going around the sun or the sun going around the Earth.
I disagree. Well, like I think maybe the audience, just in case they don't understand exactly what we're talking about, the Hubble constant is the alleged rate in which everything's accelerating away from us in all directions. Then, of course, you have the cosmological constant being the amount of energy needed to make it accelerate that fast. And then we look out there, and none of the data matches, and it's different in different places. And it's not all accelerating like it's supposed to be, and they can't even figure out how there can be a set amount of energy, and why is the energy different in different places based on distance. So that's a huge part of it. Like if we go back to when we were talking about the early 20th century, we look out, we say, oh, it looks like we're in the center. We must make up the claim that everything's going away from us, accelerating away from us, expanding. And now that very claim isn't matching the data. The data is not matching that claim. I don't know how that wouldn't be a very pertinent aspect of the discussion.
So no, it's I don't know what you mean by looking at and finding different energies in different places. As far from my understanding, our observations that dark energy needs to exist are consistent, or if it weren't, we wouldn't say that it exists. The other thing to keep in mind is while there is tension between the age of the universe from the Hubble law and the age of the universe from the CMB, they both indicate that the universe is expanding. It's not like one is essentially undercutting the other one in terms of what's physically going on. But again, it seems I'm getting the impression that there seems to be something at work which is creating a narrative. Like I think you implied in the early 20th century that there were people that being essentially silenced. Who's doing it and why?
Yeah, so
I don't know who the Rockefeller Foundation is. So,
oh, there you go. The Rockefellers own all modern publications, and I think to not notice that you're not allowed to say certain things that aren't approved would be a bit naive. I mean, even Fred Hoyle talked about that. He's like, if you come out and challenge anything in astronomy, if it doesn't fit the status quo, you simply won't be published. And Fred Hoyle lived a while back, right? I mean, so now it's much more. Well, that's a long time, right? It's much more egregious now. We just watched it. The last 3 years proved to us that you are only allowed to say what the government wants you to say. So I know it's not quite the same as like the pandemic, but it's a similar idea where approved ideas get published and certain ideas do not. And I think that's the death of science. But again, this is what I'm saying. I think that people, Michelson-Morley is a good example. Everyone assumes the Earth is going around the sun. That's just an assumed we proved it. Now, they didn't prove anything. You know, they couldn't explain Mercury's perihelion shift. The neotectonic system actually can explain it. Geocentric electromagnetic phenomena would explain the perihelion shift actually with perfect accuracy, which is one of the main ways they try to explain in the heliocentric model with the Kerr metric. The Kerr metric tries to use the charge of the sun and electromagnetism to fix the Mercury perihelion shift problem, Mercury's anomaly. But anyway, the solar system doesn't even work. But the point is, they believed it anyway. And then we get to Michelson-Morley, and the evidence does not match what anyone thought it would. It astonished all physicists. It puzzled all physicists. To quote Einstein in Relativity, Special and General Theory, like the test should have been decisive, and it puzzled many physicists. No one knew what to do, and that's like exactly how he describes it. And they didn't even consider the alternative. They literally just sat there and waited for someone to make up a new theory to explain it away. And all kinds of people, like have come out at the time. Albert Michelson himself, Edward Morley himself, all kinds of physicists came out at the time saying it looks like the Earth might be stationary. Actually, Albert Michelson said it appears. Oh no, it's Arthur Eddington said it appears that the velocity of the Earth through space might happen to have been nil. These are very famous people. That's the Eddington experiment, right? Arthur Eddington. We've never heard of these quotes. That's my point. So like, it's not that those people were all convoluted, like conspiratorial. No, they were just trying to figure it out. They had a bias. Now we only hear the cherry-picked version of it. We just hear that Einstein was a genius and he figured it out, and they won't even tell you about Michelson-Morley. Most of the time, they don't even tell you about it. You have to go find it. You hear about it in Flat Earth, but you don't hear about it in the mainstream. So there is definitely a narrative being pushed. Long story short, with Michelson-Morley, they made all kinds of unfalsifiable claims to save heliocentrism instead of accepting the data for what it says. And that's just one of many examples. This happens today all the time. Every single time. Dark matter, dark energy, dark flow, because one part of the universe is moving in the wrong direction. So like, oh, there must be something outside the universe that's pulling it or something. Like, I don't know. To me, I think it's weird. You see what I'm saying? It's not like some big conspiracy of different individuals. It's compartmentalization of propaganda that the people that are studying it were told. They believe it. I don't think you're lying about anything. I don't think your colleagues are lying about anything. I think that would be insane to think that. I'm not a crazy person that just is scared of everything and like paranoid and pareidolia. Like, no, I just know how it works. Everyone thinks evolution's real right now. It's not real. Everyone thinks it is real. So they go look at rocks on the ground and they try to interpret the rocks as if evolution's real. All right. So you see my point? That's where I'm at. Is it's just people, they don't even question their foundations. I need empirical evidence. I know I talked long. I want to let you go, and I want to give you this alley-oop, if you will. Like, I need like exclusive empirical evidence to substantiate that the Earth is orbiting the sun, that we're tilted, wobbling, spinning, revolving around the sun, because all the evidence shows us the opposite of that. All the empirical, testable, measurable evidence shows us that we're not moving. So I need some like empirical evidence, right, to go against all observations that I can directly observe, right?
So, okay. As far, I would love to see your evidence that suggests that definitively states the Earth is stationary, because all the evidence that I know of states quite the opposite. Like I said, as you've pointed out, two of them already, which is stellar parallax. You have stellar aberration. You can even go deeper and look into binary systems. You have to account for the fact that you're looking at them from the barycenter rather than the Earth, because if you don't take that into account, you're basically putting in a systematic error to the periods and the orbits, which makes things basically wrong, and so forth. So you keep saying that there is no evidence for it, but there is a tremendous amount of evidence. And you also have said that we don't look back. I don't know who you mean by we, but astronomers do look back. Actually, the first thing that we do in any paper is write an introduction. And in that introduction, we have to justify that we know what the hell we're talking about by citing previous research. So we definitely look back on the topic. What was it? There was something else. So,
all right, I know it's kind of tough when we're both like saying a lot. So
so with Fred Hoyle and ARP, ARP was another detractor who, he got maligned in scientific community, but they didn't get blackballed. They weren't like banned from publishing. So. And if you talk about compartmentalization, that, again, I don't see how the astronomical community could be compartmentalized, because the Earth going around the sun is a fundamental aspect of the universe. So regardless of what you're studying in astronomy, that holds true. If it doesn't, then whatever you're studying, something's really wrong, because our understanding of physics, basic physics, is not there anymore. So, but when you use the word compartmentalized, again, to me, that kind of invokes that there is someone who is compartmentalizing these things in order to, basically silence people who are against a certain narrative. So,
well, the compartmentalization just comes by way of propaganda, man. Like, for me to go through university to get my degree, I have to be able to recall certain information. When it's ingrained in my head enough, I do enough math to work it out. I know this because I'm pretty good at math. Whenever you do complicated math and you get it all figured out, especially when you can do it efficiently, you start to internalize it. You start to believe what's behind it. So then you believe the stories that you had to recollect and regurgitate to get your test. Like, once you get, I can only imagine, which I don't, once you get a degree in astronomy, do you think you're ever going to question some of the core tenets of astronomy? Of course not. You've gone through 4 straight years of classes. Now, will you go attack some of the fringe questions? Sure. But the base tenets, never, ever. And Michelson-Morley is the most misrepresented experiment in the modern history, and it's not even close. People still say it debunked the ether. It didn't even debunk the ether. It debunked a stationary ether. So, like, people don't even know. I talked to many physicists, professional physicists, they don't know what really happened with Michelson-Morley. The motion of the Earth is in the title of the paper. It didn't show the motion of the Earth. They changed physics to explain it away. And I do have to correct this idea. I have tons of quotes, so there's no way I can find them. But, like, you said that the motions of the planets won't even work. That is incorrect. That is absolutely incorrect. Here's one quote from Luka Popov. And obviously, I'm not appealing to these people authority. I mean, if you can articulate what's wrong with what they're saying, that's cool, right? Because I don't appeal to authority ever. But he says, but what is less known is that Tycho Brahe, Kepler's tutor, which you voiced contention with, developed a geostatic system that was just as accurate and elegant as Kepler's. The sun's orbit around the Earth and all the other planets orbit around the sun. The trajectories are ellipses, and all the Kepler's laws are satisfied. Luka Popov, Newton-Machian analysis of neo-Tychonic model of planetary motions, University of Zagreb, Department of Physics. I have tons of these. This is from 2013. Modern astronomers have already mathed it out. I have relational mechanics explaining it as well. So I don't know why. I think that's not accurate, that the planetary motion can't be mapped out on a stationary Earth. I mean, that doesn't even make sense. And I know it can be mapped out from my position. I would be invoking electromagnetism. I would be invoking a more dense medium. We clearly have a more dense medium. You guys just call it different things. Dark matter, dark energy. So I don't know. Have you ever looked into, like, why are you saying that you can't map out the planets on a stationary Earth?
So I don't know who that is. But what I can do, and this kind of goes to the questions that I've been kind of going back to, is I don't see that paper. I don't see that work. I've never been told that work. But what I can do is I can look up, Campbell in 83. He's talking about the sun's quadratic quadrupole moment, which is what you sort of inferred with the charge and all that. It's actually has to do with the internal rotation of the sun, which affects the moment of inertia, and that goes into play in describing the precession of Mercury. And they basically say, all right, the previous quadrupole moment was inaccurate. With this new measurement, or with this new analysis, matches perfectly. There's something called PPN, or post-Newtonian something or other, which takes relativity into account. It takes the gravity it takes a lot of different things into account. And that, again, perfectly matches what we see in the universe. I do not know of any studies or any research which states that can be done as a geocentric universe. And if that is the case, because I went through school, I got a degree, I worked in the field, still work in the field. Why is it that I'm not hearing this? Why is it that this is not being discussed by my colleagues?
Well, why say you discovered that the geocentric position is a viable one, and you, be honest, you decide to come out and start talking about how you're now a geocentrist, and you found out via relational mechanics that actually the geocentric position is viable, what would your life be like? What would happen? What would happen? You would get ridiculed, man. You would get ridiculed and ostracized.
Here's the thing. In order for me to basically make that claim and be taken seriously, is that I would have to show from an analytical perspective or an observational perspective that that this is correct. I can't do that. So if I could, I hate to use fallacy terms, but I think that's kind of begging the question or whatever. In order for me to do that, I would have to be able to quantify, I would have to be able to show that, like I said, analytically or observationally, and then that would go through a peer review process. Am I going to be highly questioned? Yes.
Thank you.
And I would have to have basically bulletproof proof or evidence or what have you. I'd have to have a bulletproof argument for me to be even considered.
And you still wouldn't be considered.
I would push back on that. Yes.
I'll give you a paper right now where someone's already done it. So 1999, Andre Assis, professor of physics at the University of Campinas in Brazil, relational mechanics, works out all the math, shows that relativistic application can't even predict the precession of the pendulum, and that with relativistic application, kinematical equivalent situations or systems are not necessarily dynamically equivalent. Then applies Newtonian mechanics with real inertial forces, shows that you would in fact have the precession of a geocentric position. This same guy right here, I have a quote, says in the Ptolemaic system, the Earth is considered to be at rest and without rotation in the center of the universe, while the sun, other planets, and fixed stars rotate around the Earth. In relational mechanics, this rotation of distant matter yields the force. Now the gravitational attraction of the sun is balanced by a real gravitational centrifugal force due to the annual rotation of distant masses around the Earth, with a component having a period of 1 year. In this way, the Earth can remain at rest and at an essentially constant distance from the sun. The diurnal rotation of distant masses around the Earth with a period of 1 day yields a real gravitational centrifugal force flattening the Earth at the poles. Foucault's pendulum is explained by a real Coriolis force acting on moving masses over the Earth's surface. The effect of this force will be to keep the plane of oscillation of the pendulum rotating together with the fixed stars. I know there's a lot, so you can go now and say what you want to, but I just covered this in my Relatively Speaking series. This guy, no one's ever heard of this guy. You've never heard of this paper. It's buried, dude. This dude, it's like 700 pages. It's got all the math. It shows all the math from both Newtonian and Einsteinian mechanics. Why have you never heard of it? That's what I'm saying.
So, one, he wasn't silenced because he published his paper. He published that book, and we were talking about rotational mechanics, which I am just now becoming familiar with, which is kind of ironic because it's basically, from my understanding, it was developed by Mach, and Ernst Mach was the first one to say, yeah, the ether doesn't exist. We need to come up with a better idea of what this is, which is what I think rotational mechanics was born from. Was essentially an explanation for why the Earth, or why the Nicholson-Morley experiment was a null result. And just as a kind of an aside to something you mentioned earlier, Nicholson-Morley is a very well-known experiment in the scientific community. I learned about it both at undergraduate and graduate, so it's not like it's been displayed or been thrown to the wayside or what have you. In terms of it being misinterpreted, again, we go through the math, we go through the physics, and I don't see, unless there is, I don't see how that can be misinterpreted.
What? But, did you learn in school that a possible explanation of Michelson-Morley is that the Earth is stationary? Because I mean, it is.
No, I did not learn that because that's not what the experiment tells us.
It does. The experiment tells us either the Earth is stationary, or there is no ether drift, and the Earth is orbiting around the sun, and there's a constant speed of light, and there's no absolute frames of reference. That's what it tells us. It tells us either the Earth is stationary, or we cannot have the ether we currently understand. There can be no absolute frames of reference, and there must be a constant velocity of light in a vacuum. No absolute frames to measure against. That's the two options. Yeah. We know which one they went with.
Yeah, but now that I think about it, now that I understand what you're saying, yes, that is accurate, and yes, that was proposed to us, and that was rejected because, again, from Kepler and Copernicus, we know that the sun is in fact revolving around the sun. It just is that evidence is there. It has not been refuted as far as I can that I'm aware of.
But what evidence are you saying? Just so I understand.
If it has been, then somebody is actively trying to. Someone is actively suppressing it.
Yeah.
Now, why don't?
Sorry, I didn't mean to interrupt.
Yeah, no. You say something about, you said basically you go through school and all that kind of good stuff, and you go through and you derive things and you go with math. Why don't you believe the math? Because what I don't quite understand, and this is kind of going off onto another topic, is, you seem to be going to all these different ideas or explanations, which I don't think are actually consistent with one another or even are compatible with one another. And you're fine with those explanations, which as far as I know have not been rigorously tested. But with relativity, classical mechanics, those have been tested over and over and over again and shown to be accurate. Yes, there are problems, but they've been shown to be accurate a lot of the time. So why is it you want to reject that, but go to these other fields of study that are not nearly as rigorously tested?
Yeah,
why is that math believable and this math not?
Okay, for the only reason I'm bringing up the relational mechanics paper is because he's suppressed. You've never heard of it. It shows in your own paradigm, using Newtonian Einsteinian mechanics, you have to concede that the Earth could be stationary, and you get the pendulum precession, and it's equally valid according to both Newtonian and Einsteinian mechanics. It's just to address the misnomer that somehow the gyroscope and the pendulum and sidereal rotation detection proves the Earth's rotating. It doesn't, not even using any type of mechanics that's been currently proposed for the model. As to your bigger question, I don't believe anything because it can be mathematically represented. And when you say that classical mechanics and relativity have been tested on the massive scale, I don't know what you mean, other than like you use little g on the local scale. Like I can use a kinematic equation with initial velocity, height, and time and solve for downward acceleration and do everything I do in engineering. I don't need anything to do with the bending and warping of space-time. I don't need anything like that. That's the vast majority of use cases on the local scale, is weight and downward acceleration. And that's easy peasy. I would say it's intrinsically electrostatic. That's what gives you density and weight. And that's all easy. I can use a kinematic equation. Math, the fact that kinematic equation describes it, doesn't mean whatever I claim is the cause of the time is true, right? Actually, though, when we test it more scrutiny, like with quantum mechanics, where we get really hyper precise, repeatable observations, it doesn't work. So neither one of those things can be accurate depictions of reality. What I want to know is, how come we don't take the evidence to say what it really says? Which is, see, I look at everything, bro. You're right. I do look at a whole bunch of different things. It's because I'm just trying to sift through and figure out what's going on. I know that I'm not going to conform to like consensus. Consensus is always 100% of the time wrong. Every single time. It's always wrong. It's guaranteed wrong right now. And when we look at quantum mechanics, there is impedance in free space. A vacuum has impedance. There's electromagnetic energy in a vacuum. And this is what people used to call the ether. So why, if the vacuum is impeding things, then why are we not addressing the possibility of there being an ether? And what I found out was there's only one reason, and it's because of Michelson-Morley. And if there is an ether that has substantive qualities and causes impedance, then Michelson-Morley would have showed a fringe shift if we're going around the sun. So that's not even on the table. That is why we have a disconnect between quantum mechanics, the local scale, and cosmology. That is why. And why would I fall into that trap? I get it sucks, bro. I get that it sucks for people in your field that their whole life that they wouldn't explain cosmology, and then people's whole life they wouldn't explain quantum mechanics. And now there's this huge gap, and both people are going to have to let go of what they think they thought they knew. But that's not, I mean, pride will just be the death of knowledge every time. So That's the way I look at it. I look at it on the meta scale. If there's an accurate theory of physics, it's going to explain everything. It's going to apply on all scales. And right now, it doesn't. And so then I got down to the bottom of why we're not fixing that problem. And it's not lack of information. It's a philosophical bias. So that's kind of my long-winded way of answering your question. I think.
Okay, so I want to ingrain that. I want to go back to the philosophical bias. As I said, I'm just now getting into rotational mechanics, but two of my friends, Eric E. and I Can Science That, have basically talked to me about it, and they have assured me that it has been well studied and refuted. But again, you have to contact them to find out exactly why.
In terms of gravity, rotational. You mean like relational mechanics?
Yeah, sorry, relational mechanics.
That's all good. Yeah, okay.
In your description of kinematics and gravity, and I could quibble about the fact that gravity really isn't kinematics per se, but what you're describing is classical mechanics, and classical mechanics is Newtonian gravity. So the fact that you say that works, and you're correct, it does work, really basically is an admission that Newtonian gravity works, because you can't use I won't say you can't. I have yet to see an electrostatic derivation that will allow me to predict a block sliding down a ramp. The classic inclined plane experiment. This is the experiment that Galileo used to make the statement that in the absence of air resistance, masses accelerate at the exact same rate regardless of their own masses. So if you can explain that, and I can derive it, I have on my channel, if you can derive that relationship using a density approach, a RDD approach, or an electrostatic approach, I will certainly pay attention. But as far as I know, the only way that I've been able to see it done accurately, and since I've taught physics labs, I have done that lab more times than I can count. The only way to do it accurately is through Newtonian gravity. Now, I find it interesting that you said consensus is always wrong. Why? What is it about consensus that makes it wrong? Because you could say that there's a whole lot of consensus that God exists. So
yeah. I mean specific to this conversation. So scientific consensus, certainly in terms of physics, it's always wrong. Like even on just a basic logical level, it's going to always be updated. We're going to figure out new things. But oftentimes what people slide in there real fast is the presupposition that we're always getting more accurate. That is not correct. That's absolutely not correct. A perfect example is doing away with the ether. We're going to, mark my words, the ether will return. The ether went nowhere. There is no way to explain physics without the ether. But why is it gone? So if we go back to the ether, did we progress this whole time? No, we wasted 100 years, and now we're going to have to take a giant step back. Now, sure, we have lots of new information we've gained since then that we'd be able to integrate into our ether model to better understand ether, right? But it's a presupposition that it's always going forward. I guess my point is, I use Einstein as an example to make this point. When Einstein went to the Royal Astronomical Society to propose his theory of relativity, he got laughed out of the room. They didn't want to hear it. They're like, what are you talking about? You're a crazy person. And he was a crazy person. But anyway, he got laughed out of the room, right? And now that's the mainstream consensus, the theory of relativity.
Correct.
So that's my point. Everyone believed in the Newtonian framework. Everyone believed in ether. Now, everyone mocked anyone that would believe something as crazy as there's no ether and there isn't an absolute frame of reference. Now everyone believes that. Okay, so even just the current, like even Einstein himself shows you what I'm saying is true. Now that doesn't mean that I can just run around and just claim everything's wrong. I'm not saying that. I'm just saying that I know that consensus is the easy way out, and every person that's ever made a discovery in science went against the consensus. Every time. Whoever solves the dark matter problem would have to go out of the consensus. It's not just dim matter. That's a cop out, and it's honestly it's just the ether. It's just the ether, dude. You get what I'm saying, though. You get what I'm saying. We are currently in a state where we can't unify the different scales. And if we're going to make a theory about the natural world being natural science, we need to experiment and test it, and it needs to apply at all scales everywhere that physics applies. So if we're making a claim about mass, it should apply everywhere mass is. And that doesn't exist. And I'll let you talk plenty long because I'm kind of rambling. But to address your mass part specifically, or Newtonian mechanics, classical mechanics, Newtonian mechanics, yeah, I was only pointing out that if you revert back to Newtonian mechanics, you have to concede the geocentric Earth is valid position. And of course, Einstein told you himself that due to the covariance and equivalence principle, that a geocentric Earth is valid. I obviously don't believe any papers written about it. They all assume the Earth's a sphere, and you know that I don't believe that.
Yeah.
But you get my point. I just point out that people misrepresent this conversation in many ways.
So again, I'm going to push back on the idea that Newtonian gravity is consistent with a geocentric universe. It isn't. It doesn't even doesn't explain doesn't explain the precession of Mercury. It doesn't explain gravitational lensing. It doesn't explain time dilation. Doesn't explain muon decay. It really fails on a lot of different levels. But on a terrestrial scale in everyone's everyday life, yeah, it's a very valid tool, because what people are doing usually isn't precise enough for the effects of relativity to really creep in. Now, you've said that essentially, I think you've said that you claim that we progress kind of through a philosophical. But now I want to wait on that. The other thing I want to say is more towards yes, as far as every revolution revolution or scientific revolution that I am aware of, specifically in dealing with physics or astronomy and cosmology, yes, the person who put it forward initially was ostracized. We see this with Copernicus and his fears against the church. We see this with Galileo and his house arrest. We see this with, as you rightly pointed out, Newton or Einstein was not taken seriously in the beginning. Newton wasn't taken seriously in the beginning either. And they were eventually proved correct. Well, not proved correct, sorry. Their ideas were eventually accepted because the preponderance of evidence showed their ideas to be the best description. And so I fully believe that GR will in fact someday be superseded. And I hope it is, because you're right, it doesn't explain, there is no coupling between GR and quantum mechanics. And so eventually it is going to have to be superseded. That's how science works. That's the scientific revolutions. I recommend reading either Karl Popper or Thomas Kuhn on these subjects. In terms of going back to the philosophical bias, again, when you think of consensus, what I'm hearing, and I could be wrong, what I'm hearing is that you think that we're just accepting things, that we are just basically be given information from our forebears, and we're like, okay, that's cool. We're not. We are doing observations which, to quote, paraphrase or quote Newton, we are standing on the shoulders of giants. We are basically building our current understanding on their past understanding. And yes, there are going to be crises that test our current understanding. But if you're an honest scientist, you're going to go where the science leads you. And when we say that we have a consensus belief that the ether doesn't exist, it's because there is no real evidence to suggest that it does. Nicholson-Morley, essentially, that's the null result. As you stated, there are only two possibilities. The Earth is stationary or the ether doesn't exist. And so, like as I said, Mach took that and said, no, the ether doesn't exist. And Einstein eventually came about, and there was some playing around. Well, Lorentz and Poincare had some ideas, but they lacked any kind of physical meaning. But it was until Einstein's GR that you actually had a physical mechanism for why you would expect that null result to occur.
Wait.